My name is Aleksandra Kaszubowska. I'm assistant professor at Trinity College Dublin, and I'm the coordinator of ICON project. What excites me about ICON is that it is a first step towards making the fiber sensing a truly integral part of the optical network. Achieving this goal will allow us to fully exploit the benefits of fiber sensing, including improved network performance and increased infrastructure protection and resilience.
So I'm Professor Marco Ruffini. I work in the School of Computer Science and Statistics in Trinity College Dublin, and I'm part of the Connect Research Center. So in ICON, I look at Work Package 5. So Package 5 is basically around the networking, around sensing, and the key challenge is how do we turn sensing from a link type of service, which senses one link at a time, to something that's scalable to a network-wide. So it includes things like, how do you use a small number of probes to sense a large part of the network to be more cost-effective? Look at the things like, if I detect an event, how can I redirect more sensing probes towards that event so that I can recognize it better? And the overall over the time, as I get more and more information about the network, the idea is to start building context around the network. So as soon as then I pick up some strange signals, because I have a much better context, I can understand a lot quicker what's really happening into the network. I mean, the impact is big because people have realized that there's billions of kilometers of fiber around the world, and in principle, all of them could be good for basically sensing activity, fiber-based sensing activities. So it explores the richness of already available fiber. It gives even operator initially way of monetizing their network, because the traffic growth of internet keeps growing, but it's kind of so saturating. So this gives a completely new economic, let's say, way of selling the network. So if I had to sum up ICON with 3 words, I would say, first of all, essential, because it can help to protect the infrastructure, and we know today that's more and more important. It's going to be highly relevant to where networks are moving. And as a third word, I would say innovative, because they're really coming up with new ideas. Might have been around for some time, so just a way of implementing this idea that has never been taught before.
Hello everyone, my name is André Sandmann from the Advanced Technology team at Adtran in Meiningen, Germany.
Hi all, my name is Florian Azendorf from the Adtran Infrastructure Monitoring team at Adtran in Meiningen, Germany. Adtran is a leading provider of optical networking systems spanning core, metro and access, and we offer infrastructure assurance and precision timing solutions. In ICON, multiple teams from Adtran in Meiningen and Lüneburg are involved. Together, we cover transmission and fiber sensing systems across all layers. Adtran's focus in ICON is to seamlessly integrate fiber sensing into telecommunication networks. This has the potential to use the 8 billion kilometers of optical fiber that are already deployed worldwide, not only for data transmission, but also for sensing applications at the same time. In addition, we develop novel fiber sensing technologies based on backscattered light and transceiver data. The holistic solutions that we are developing together with all ICON partners are designed to support network operators in identifying and resolving effects from critical events that pose a significant risk to their fiber infrastructure.
Hi, my name is Bernhard Schmauss. I'm professor for photonics at the University of Erlangen-Nürnberg in Germany. I'm leading the ICON project, part of FAU. ICON is a fascinating project that compares and correlates various sensing modalities to create an overall picture of the fiber infrastructure and its environment.
Hi, my name is Elisa Morón and I'm project manager at CYRIC, the Cyprus Research and Innovation Center. Our main role in ICON project is that we are the leader of Work Package 7 that is related to dissemination communication, clustering and exploitation of the results. Our main goal after ICON project's end is go beyond the end of the project, so we can reach and make accessible all the results obtained in the project.
Hello, my name is Iacovides, I'm from CYRIC, and I'm a software developer and UI designer.
And I'm Yerontides, a software developer at CYRIC as well, working on the ICON project.
For the ICON project, we have to develop the cloud infrastructure, which is particularly interesting because of the large volume of data generated by fiber sensing. The data generated at the edge will be transferred in the cloud and stored in a data lake, which will enable context generation by combining several data sources. The cloud infrastructure will be responsible for collecting all the data and making them available for further data analysis and later to be visualized in the smart interface, which my colleague will develop.
For the smart interface, we aim to provide the central web accessible interface that will display events, context regarding the event, and other data collected by the project to provide a complete picture for the state of the deployed network.
Hi and welcome to the ICON project from us at Friedrich-Alexander University in Erlangen, Germany. I'm Lukas, I'm a research assistant at FAU, and our research focuses on distributed optical fiber sensing and the investigation of novel fiber types.
Hi, I'm Esther. I'm also a PhD candidate at FAU in Erlangen. Within ICON, we also tackle the digitalization of optical fiber sensors by implementing a digital twin model of the ICON system.
Hello, I'm Hendrik Johann Kerm.
And I'm Torm from TalTech in Estonia.
We are working in the Optical Communications and Sensing Research Group together with Dr. Kaida Kaeval.
Our goal is to develop new means to monitor mission-critical infrastructure through utilizing commercial telecommunication networks and state-of-the-art fiber sensing technologies.
This is our university campus, and this is our lab.
We are super excited to contribute to the ICON project as improving network reliability
and developing the availability assistant application can greatly accelerate the developments of the Baltic Sea sensing grid.
Hello, my name is Kaida Kaeval and I am also from TalTech. And in the ICON project, we are responsible for leading the work package 2, which is about use cases, physical requirements, and data formats for the sensing systems. So first, we have the transceivers which are installed in the ends of the telecommunication lines, and we can collect the telemetry data in order to increase the visibility of the infrastructure. Then we can add also the amplifier telemetry data, which would further increase the visibility by hop. And in the end, of course, the end goal is to install the distributed acoustic sensing on top of the fiber infrastructure in order to gain the spatial resolution into the seized infrastructure.
Hello, my name is André and I'm General Manager of EPR Photonics. We are based in Berlin, Germany.
And my name is Johann from the Project of Technology in EPR Photonics.
EPR Photonics provides professional design and simulation software for a wide range of photonic applications, in particular optical transmission systems. Our advanced fiber models account for various linear and nonlinear effects, including chromatic dispersion, kernel-rarity, Raman scattering, and more.
And within the ICON project, we are developing a new generation of fiber models, system models, that can be used to simulate distributed sensing applications. The fiber models take into account time-resolved relay, Raman, and Boolean backscattering, while the interrogator models simulate coherent and direct detection, including digital signal processing algorithms.
By combining these new and existing fiber models, we aim to study different coexistence scenarios where transmission and sensing systems operate over the same piece of fiber. Also, we provide simulation support for our partners who work on the very different use cases within the ICON project. Thank you.
Thank you.
Hi, my name is Juan.
And I'm Roman Yilmaz.
We are postdoctoral fellows at the Technical University of Denmark, working in machine learning and photonics group. One of the goals is to push the limits of fiber sensing by developing real-time signal processing techniques based on cable filtering to estimate the amplitude and phase of a radio backscattered signal in coherent OTDR systems. By doing so, we aim to counteract multiple noise sources in OTDR technology and move the achievable sensitivity of these systems closer to the quantum limit.
This improved denoise signal can then be used to extract valuable information from the measurements. To achieve this, we are modeling relay backscattering under dynamic conditions, where certain fiber segments experience temperature or strain changes. Based on these models, we are developing neural network architecture capable of identifying different types of events, and finally, we investigate the fundamental limits of such measurements.
Hi, my name is Mariano Divigini. I'm an engineer at License AI, a spin-out company of the Trinity College Dublin, located in Ireland. In ICON, we are focused on the research and development of optical sensing method to monitor the performance of the optical network, with the ultimate goal of improving its resilience and availability.
Hi, I'm Petr Minister. I'm the professor and fiber optics group leader at the University of Technology. Our group has been working with joint sensing and data for more than 10 years. We also have a well-equipped laboratory and testbed for evaluation different types of signals and their mutual interaction. But ICON is not only about joint sensing and data. It's about smart, resilient infrastructure which enable us to measure temperature fluctuations, strain or digging activity near critical infrastructure.
Hi, my name is Tomáš Horváth and I work as a researcher at the Brno University of Technology. Brno University of Technology is involved across all ICON work packages, integrated knowledge from sensing, data processing, and infrastructure assessment into the project architecture. We have access to both in-house developed and commercial sensor systems for comprehensive experimental validation. Within ICON, Brno University of Technology leads Work Package 6, contributing to sensor data structure, use case definition with partners, implementation and evaluation of testbeds, and the validation, documentation, and dissemination of project results.
So I'm Dan Kilper. I'm a professor of future communication networks at Trinity College Dublin and the director of the Connect Center. So I'm one of the Trinity College Dublin co-PIs on the ICON project. So there's a number of different things that we're doing within ICON. One is innovating around new sensing technologies, and especially we're excited about sensing technologies that are a part of the communication system and tell you something about the quality of your communication system, as well as giving you sensing and context around the cables and other types of applications related to where the fiber is being transmitted and how it's being used. So you get this new capability of sensing together with advanced monitoring that gives you data that you can use for AI control of your networks or refining the performance of your networks. So I'm really excited about ICON because it's a project that goes all the way from the core underlying technologies and innovating in that space up to the control and management systems that you need in order to integrate that sensing as part of a whole communication system. Really make it intrinsic to the communication systems and our larger technological ecosystem. And it really covers that entire space, and that's what I'm most excited about in the project.
It is fantastic to work with this great consortium, consisting not only of outstanding researchers, but simply incredibly nice people, and to work on delivering tangible, positive impact for our society, economy, and security.